If you frequently work with assemblies in SOLIDWORKS, you may be familiar with the various advanced and mechanical mates, such as the gear mate or the rack and pinion mate, like you see here. While these mates can be helpful, it's important to remember that in SOLIDWORKS, mates only simulate the positioning of a component based on its geometry and are not representative of the physical interaction between the components. Here, I have a simplified assembly model of a ratchet. If I zoom in on the ratchet head, notice that the gears here are mated in such a way that they're free to rotate, but cannot be moved or dragged. This was done using regular coincident and concentric mates. Also, notice you can rotate the gears to a position where the teeth are overlapping, which would be physically impossible because the actual solid parts would collide. The mates do not recognize the physical interaction between the gears. So, is there a way to simulate a ratchet-type motion in SOLIDWORKS? The answer is yes. However, no mates currently exist in SOLIDWORKS that can simulate the motion of a self-limiting mechanism such as a ratchet. In order to view how a self-limiting mechanism will operate in reality, it's necessary to take the physical interactions between components in contact into consideration. While this cannot be done using mates, SOLIDWORKS does provide tools that allow you to do this. To accomplish this, I'll launch the Move Component tool from the Assembly toolbar. The Move Component tool is very useful, and you can do much more with it than simply dragging components in an assembly around the graphics area. In the Property Manager, under the Options section, notice that outside of the standard drag, I also have the ability to perform collision detection and physical dynamics. Using the Move Component tool with either of these settings will take the physical interaction between components into account, which is what we want. Since this is a gear mechanism, we actually want these components to collide. So instead of using collision detection, I'll select the physical dynamics setting to view the motion of this mechanism. As a quick side note, since this tool is analyzing the physical interactions between parts, this can be very processor intensive. I'll click and drag the center gear to simulate the motion of the mechanism. Notice that I'm free to rotate the center gear counterclockwise. But if I try to rotate this gear clockwise, I'm unable to do this because the bottom component restricts the motion.